Next we have Diego Moreno from Bull, who's going to be talking about Lustre 2.1 and HSM. Diego Moreno.
Thank you.
Thanks, Mom.
So, my name is Diego Moreno, and I work for Bull. And I'd like to present you today work we've done with LustreHSM, especially this work done in a new cluster in Japan. So this presentation shows the work by several people from several companies, and I'll talk first about Bull, who we are. Then I'll show you how we use Lustre in a new petaflop cluster we installed at Japan. Especially for this cluster, the need of having a LustreHSM infrastructure. So I'll tell you what's LustreHSM, how it works, and the current status of this project. Finally, as LustreHSM is just an ongoing unfinished project, also how we solve today the need of having a backup file, Lustre file system, and how we expect to go through LustreHSM in the future. So who is Bull? Bull is the first European constructor in the HPC. During the last 18 months, we have installed 3 petaflop machines in 2 different continents, Europe and Asia, which is for us a great success. And to see how Bull is progressing in the HPC, I think we have a good proof seeing how many clusters we had in the top 500 list for the last 3 years. In 2008, we had 3 clusters, and today we have about 15 clusters. So please, in the vendor table, when my boss is coming and talking to you about Bull and saying who knows Bull, please raise your hands or I'll have a problem. So how is Bull contributing to Lustre, and where are we placed in the Lustre community? Well, Bull is one of the members of the IFERC community Hugo Falter presented you this morning. Bull is also, we have contributed to stability of the Lustre 2 branch, along with CEA being the first Lustre 2.0 adopters, and performing the first Lustre 2.1 installation on a petaflop machine. We have also contributed with some other developments, such as or some other work, such as, for example, the NUMA input-output architectures in Lustre, as you could see in previous lag events. One of the other works we've done is the adaptations for the kernel to Redux 6. So Bull has recently installed in Japan a new petaflop machine we call Alias. The Alias is going to be used in the IFERC project. With Alias, we obtained a link pack performance of 1.52 petaflops, and actually the link pack test was run in later than November 2011. So, but if it was it would have been run before November, it would be in the 6th position in the top 500 list. Within this cluster, I'd like to speak about its file system properties, as we could expect being at look. So at Alias, we have 2 kinds of Lustre infrastructures containing 2 different Lustre file systems. So for each Lustre infrastructure, we'll have 1, 2, or several Lustre file systems. In the first kind of Lustre file system is contained in what we call the L1 infrastructure. And this is, for example, the case of a typical Scratch file system, which needs high I/O throughput. This kind of file system is contained in an infrastructure composed by 48 bull OSS, 4 bulls MDS, and 13 DDN storage arrays. And the final throughput is about 110 gigabytes per second. And then there's a second kind of Lustre infrastructure we call L2. File systems belonging to L2 are worse performant than the ones contained in L1, but however, L2 has higher storage capacity. This L2 infrastructure is composed by 12 bulls OSS, 2 bulls MDS, and 4 DDN storage arrays. But the most interesting point I'd like to talk to you today is the connection between this L2 Lustre infrastructure and the SGI's DMF type device. Here you can see a diagram of this connection. SGI's DMF manages a set of tapes and servers, giving us more than 40 petabytes of extra storage capacity. And this device is what we call a typical HSM device. Our purpose at Alias is to be able to move data from Lustre to the HSM device, from the HSM device to Lustre in an automatic way. Furthermore, we want to free space on Lustre, moving data from Lustre to HSM, but keeping a stub of the metadata on the Lustre file system. Let's see an example. So for a given file, we would choose to migrate all the data occupied by a Lustre file to our HSM device, but keeping the associated metadata on Lustre. That way, Lustre could see this file as an empty file, but it's still there. And then, under user access on the file, that would provoke to recover the data from the HSM device to the OSTs. And this feature should be integrated in Lustre. That's what we call LustreHSM. So in the next part of this presentation, I'd like to show you more about the LustreHSM project and its status. So it's been mainly developed by CEA. You already had some presentations in other Look events. And among the main features provided by LustreHSM, as we have migration to an external storage, free disk space, as we've seen in our example, and also disaster recovery, having a backup solution. And LustreHSM brings new components to the Lustre architecture, such as the coordinator, the archiving tool, and the policy engine. So how it works? The coordinator running on the MDS gathers HSM requests for a file, and this request could be, for example, archive a file, release the space occupied by a file, or restore the space, restore data again on the OSTs. This request could imply an action by the agents, such as copying data from Lustre to the backend storage, vice versa. And in this case, the coordinator will dispatch the request to one of the agents it has on its list of agents. And these agents previously registered on the coordinator these agents are obviously connected to both Lustre and the HSM device. So, as we want to do all these LustreHSM operations in an automatic way, we use a policy engine. This policy engine, Robinhood HSM in our case, send requests to the coordinator. These requests are generated according to the migration policies we are previously set, which depends, for example, on the size, the owner, or the name of the file. We can set also other parameters such as last modification or access time on the file. So, how do we have LustreHSM code integrated in Lustre? Well, there are several patches. On these patches, there are some bug fixes we apply on top of the Lustre 2.1 branch. This is the the first third patches you see. Some of them are already landed in Lustre 2.2 or Lustre or the master branch. There's still another one under inspection. And there are also obviously the feature patches, which they bring some necessary new features for having LustreHSM, such as, for example, the POSIX copy tool, or the coordinator, or the new layout log. I'll talk later about the landing status of these patches and the roadmap. But first, let me talk to you about the most important patch we have today in LustreHSM, which is the new layout log. So the integration of the new layout log is a complex work. Right now, this patch is being reworked at OneCloud. And the patch has been split on 4 different patches. 2 of them are already landed or ready to be landed, and the other 2 need to be reworked. And with this new layout log, there are some important changes. For example, clients will be aware of the layout log version they have, or there will be some new fields on striping information. This new layout log is also important because it opens the door to new developments, such as, for example, OST rebalancing or dynamic restriping of a file. So obviously, all these changes on the Lustre code requires a lot of testing. And this is what is being done by several companies and research laboratories, such as, for example, SGI or CNES for the project Praise, or CEA and Bull. We are testing LustreHSM in 2 different facilities. So our main contribution to LustreHSM has been testing the code. We've done several testing phases on different Lustre infrastructures. We first test basic functionalities such as migration, releasing and restoring of the files, and we did it in a basic configuration with only a few machines. So several OSTs allowed us to test the new layout log, discovering some important bugs we had. Then we used also a local disk storage, which allowed us to test the POSIX copy tool. And at the end of this test, we had a pretty stable configuration with still some workaround in place, but fully functional. And in the second phase of our test, we chose to make a proof of concept at Alias, the cluster I presented you at the beginning. So this time, in addition to the functional test, we could test how the code reacted to moderate I/O load. Comparing to the first test, we had some more OSTs, some clients making intensive I/O work, more than 1 copy agent. This time, the backend was on a storage array and not a local disk. And this test raised some bugs with the changelog functionality, which is intensively used by the policy engine. And there were also some minor bugs with the copy tool balancing load on agents. So the policy engine was also intensively tested, with, for example, the creation of 3 million files to be migrated, which in fact raised these issues with changelog. We also tested the accuracy of the policies, which actually gave us very good results. But the conclusion with this test is that even if we are not still using this code in a production environment, this is quite stable. Finally, at Bull, we already planned the next step in our test. The objectives will be to generate high I/O load, to continue to test the robustness of the changelog feature. And we'd also like to test the landed LustreHSM Jira tickets. High availability is also some of the things we'd like to test in our next stage. And finally, we'd like to test what we call the transition feature. This comes from the case of an already backed up Lustre file system, which we want to change into a LustreHSM file system. The problem is, if we already have all the data migrated, we don't necessarily we don't want to recopy all this data again in the backend system. So what's the roadmap and status of this project? Well, it's important to note that this is only an estimation and not a fixed roadmap, just in case you had any doubt. Basically, a LustreHSM compatible client may be supported in Lustre 2.3. That means compute nodes will already have a new layout log and some other feature, but they won't be able to perform HSM actions. That would allow us to use these official clients, such as with a few HSM full clients. And these HSM full clients will include the possibility to have a POSIX copy tool, to use a policy engine. And these full HSM clients would be integrated in Lustre 2.4. And finally, LustreHSM server could be in Lustre 2.4, but I think it's still too soon to know when exactly the server side is going to be integrated. Here is the tile of the patches. One landed to be in rework and some others about to be submitted. So having this into account, we come back to our Alias cluster and the need of having backup, having the Lustre file system in backup. So we don't still have LustreHSM code landed. How do we solve this problem? So, well, as I say, we need to make regular backups of the Lustre file system and the DMF file system. We use Lustre 2.1.1. And as we have 8 petabytes of Lustre storage capacity, we won't need in the midterm to free space on the Lustre file system. So that's why we choose to have a backup solution. We do Lustre backup using the Robin Hood backup tool, which is a bit different from the Robin Hood HSM tool we've been talking till now. There are many advantages with this approach. First, Robin Hood backup will read the Lustre change logs. It won't necessarily make a scan of the entire file system. We specify the migration policies according to many different parameters, such as the same we had with LustreHSM. We can also have a soft remove functionality, allowing us to recover a file if there was a mistake with the file removal. Finally, and not less important, the files are already copied on the backend device. This could allow us to have the possibility to upgrade to LustreHSM without needing to recopy all the data from Lustre again to the HSM device. So let's see how Robin Hood backup works. Robin Hood backup is the core of the backup solution. With its MySQL database and written Lustre changelog entries, Robin Hood backup knows the state of every file. Knowing the state of every file, the backup policies are regularly run. When the tool detects that a copy of removal must be done on the backend file system, it runs commands on the copy agents thanks to the copy wrappers installed on them. And meanwhile, the copy agents, they have access to both file systems, Lustre and XFS, and they perform copies and removals and their request to Robin Hood backup. And then copies are done from the XFS file system to DMF, but that's outside our domain. Actually, we use XFS because it's a POSIX file system, and we use the POSIX copy tool. We have several XFS clients giving us the possibility to have a proper scalability. Robin Hood backup will be sending requests to all of these copy agents. So this one is the schema of the current backup solution in place. We see how Robin Hood backup is the core of the backup system, and how Lustre and DMF, our HSM, are connected thanks to the copy agents with access to XFS. Finally, what we will have at midterm? Well, we'll maybe need to free some space occupied by the Lustre file system and by migrated huge files. And at the same time, we'll have all the files contained in the Lustre file system already copied. So that means some petabytes of data we wouldn't like to recopy. Finally, we'll have a system in production with limits the upgrade time. So that's what we expect in the future, to upgrade the system to LustreHSM, which could be around Lustre 2.4, as we have seen. But the ideal solution would be to say to our Lustre file system, okay, this is your backend HSM file system, and you've already copied some of the files, so this is the link between the files. So this solution would be based on the update of some metadata attributes. For 2 of them, it's already possible to update these attributes, and for the last one, we have still to develop a solution. The way to do this would be daily with the help of a new LustreHSM command, a kind of link feature, allowing us to point to the already migrated file. So just to conclude, I'd like to say I presented LustreHSM as something real, with code landings, with expected landings on the way, and testing being already done by several companies. The XFS is coming, and it could LustreHSM, it could be a good and scalable solution with a good hierarchical. It could be a good hierarchical solution. And not less important, LustreHSM is a development with all the Lustre community involved in it, from UFS, for example, with CO developments and bull testing in many different infrastructures, to open SFS, with the technical working group being implied on this development. And if you are interested in seeing LustreHSM in action, please ask me, and I'll be pleased to show you how it's working today in our LustreHSM lab. Thanks for your attention, and if you have any question.
Quick question. So you were using the POSIX copy tool for interfacing with the SPI, but you didn't write a dedicated copy tool for the SGI archive?
We are not using any copy tool right now. You mean with the backup solution? With the backup solution, we use just copy wrappers installed on the agents. So it's basically a remote CP. The POSIX copy tool is just in the case of LustreHSM infrastructure.
Maybe I can